In this video, let's learn how to solve for the value of y in this nice Olympiad maths question. We are asked to find the value of the fourth root of y plus the sixth root of y equal to 12. And y are elements of real numbers. How do we find this? Don't forget to give this video a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified maths content. Now, to solve this expression, we are going to change this fourth root and this sixth root to exponents. Now, how do we do that? If we convert the b root of a into exponent, that will be a to the power of 1 divided by b. So, this is going to give us y to the power of 1 divided by 4 plus y to the power of 1 divided by 6, and this will be equal to 12. Now, in the next step, we are going to consider the lowest common multiples of those two exponents. If we have 4 and then we'll have 6, what will the lowest common multiples be? This will give us 2. 2 divided by 4 will give us 2. 6 divided by 2 will give us 3. 2 can still go. 2 divided by 2 will give us 1. 2 divided by 3, not possible. Then 3 can go to give us 1 and 1. So this multiplied by this will give us the what? The lowest common multiple, which is equal to 12. So having seen that, we are going to let the value of our y be equal to p to the power of 12. So that means wherever we find the value of y, we'll replace it with p to the power of 12. So this is going to give us p to the power of 12 all to the power of 1 divided by 4 plus p to the power of 12 all to the power of 1 divided by 6, and this will be equal to 12. In the next step, the exponents will multiply, and this will give us p to the power of 12 multiplied by 1 divided by 4 plus p to the power of 12 multiplied by 1 divided by 6, and this will be equal to 12. So this is going to give us p to the power of 3, because 12 divided by 4 is going to give us 3, and then 12 divided by 6 is going to give us 2. So this will give us p to the power of 3 plus p to the power of 2. If we subtract 12 from both sides, this will give us 12 equal to 12 minus 12 is going to give us 0. So that is a polynomial equation, since we have the highest power to be equal to 12. So our job is to simplify this polynomial equation to find the values for y. So to simplify this polynomial equation, we have 12, and that 12 can be equal to negative 8 minus 4, right? Because 8 plus 4 is going to give us 12. So I'm going to input that value of negative 12, which is equal to negative 8 minus 4 into that expression. And this will give us p to the power of 3 plus p to the power of 2 minus 8 minus 4, and this will be equal to 0. So if we simplify this, we're going to have this expression to be p to the power of 3 minus 2 to the power of 3 is 8 plus p to the power of 2 minus 2 to the power of 2 is 4, and this will be equal to 0. Now I want us to consider these two expressions and then convert these two expressions to algebraic expressions. If we convert them to algebraic expression, we recall that in algebra, if you have a to the power of 3 minus b to the power of 3, this can be equal to a minus b multiplied by a squared plus the first and second ab plus b squared, right? And if you have a square minus b square, this is a diff of 2 square, and then we'll have a plus b, and then we'll have a minus b. Now, if we insert it into this expression, those expressions will now give us, remembering that our a is equal to p and our b is equal to 2, that expression will now give us p minus 2, right? P minus 2 multiplied by p squared plus 2p plus 2 square, right? That's for the first expression. And then we'll have plus p plus 2, and then we'll have p minus 2. And all these will be equal to 0. So from this expression, you're going to see that we'll simplify. Simplifying that expression, we'll see that p minus 2 is common, so we're going to isolate it. And if you divide all this expression by p minus 2, we'll be left with p squared plus 2p plus 4, right? If you divide this whole expression by p minus 2, we'll be left with plus p plus 2, and all these will be equal to 0. So from this expression, we're going to have our p minus 2, right? And then we'll have this to be p squared, 2p plus p is going to give us plus 3p, and then 4 plus 2 is going to give us plus 6, and all these will be equal to 0. So having this zero product rule, we are going to have the first case as our p equal to 2, because we're going to have our p minus 2 to be equal to 0. And in the second case, we're going to have our p squared plus 3p plus 6 to be equal to 0. So p equal to 2 is the first solution to that polynomial expression. To find the second expression, we are going to solve the second and third expression. We are going to solve this polynomial expression. Now, this polynomial expression, are they going to give us real number? Remember, we said the value of the result of y must be elements of real number. To determine if this quadratic expression will definitely give us real expression or real numbers, we have to find the discriminant, and the discriminant will be equal to b squared minus 4ac. Now recall from here that our a is equal to 1, our b is equal to 3, and our c is equal to positive 6. So if we simplify that expression by inserting the value of a, b, and c, our discriminant will be equal to b squared, which is 3 squared, minus 4 multiplied by 1 multiplied by 6. So this will be equal to 9 minus 4 times 6 is going to give us 24. So if we check that expression is going to be equal to 9 minus 24 is going to give us negative 15. And a negative 15 is less than 0. So since it is less than 0, we have no real what? No real solution, because the solution over here is going to give us imaginary solution. So as a result of that, we are going to leave this solution, because we are actually looking for real solution, real values of y. So the only real solution we have is y p equal to 2. Now recall from that expression that we said y is equal to p to the power of 12. So to find the value of y, because that's exactly what we are looking for, the value of y is equal to p to the power of 12. So if p is equal to 2 as the only real solution, then the value of our y will be equal to 2 to the power of 12. And this is the solution to that expression given to us up there. Now, to check if the solution is actually right, we're going to insert the value of y equal to 2 to the power of 12 into the original equation given to us. Fourth root of y plus sixth root of y will it be equal to 12? Let's check it out. We have the fourth root of y plus the sixth root of y will it be equal to 12? Let's check this. This will give us the fourth root of 2 to the power of 12 plus the sixth root of 2 to the power of 12. Will it be equal to 12? Now the fourth root of this is going to give us 2 to the power of 12 multiplied by 1 divided by 4 plus 2 to the power of 12 multiplied by 1 divided by 6. And this is going to give us 2 to the power of 12 divided by 4 will give us 3. And this will give us 3 plus 2 divided 2 to the power of 2. If we simplify this expression, is it going to give us 12? Let's find out. 2 to the power of 3 is 2 times 2, 4 times 2, 8, plus 2 to the power of 2 is 4. So 4 plus 8, is it going to give us 12? Yes. So 12 is equal to 12. So that simply tells us that the value of y equal to 2 to the power of 12 is the only real solution or real number that satisfies that expression given to us up there. I know you did enjoy watching this math solution. Don't forget to give it a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified Olympiad content. Thanks so much for watching, and bye-bye for now.